About a year ago, I made a video kind of sort of demoing my HP 8660 synthesized signal generator, and for me it was a upgrade from my analog signal generator. And over the course of the year, I've really come to enjoy this device. Yeah, it's big, it's heavy, but man, does it work. And work it does. It's definitely a fantastic machine, and I enjoy it immensely. Like I said, it weighs 63 pounds, so it's not very nimble, very easy to move about when you need to. Probably about 4 months or so, 5 months after I shot the video and acquired this device, well, what can I say? That's right, I bought another one. So what we're going to do with this one here today, that one there I didn't really get a chance to tear it apart and show you because it's hefty, and I think I opened up the bottom on that one and saw that it was all encased and fused. I'm going to go ahead and try to open this one up and see if I can get a little bit further. I don't want to completely disassemble it, but get a shot of what it looks like inside. And by the way, in case you haven't noticed, I'm on Wiggly Cam. I feel that for this, it would be a lot better than trying to do a stationary camera at the moment. So hope I don't get you too motion sick. Like that one, this one here has the same modules into it, which are these, the modulation section and then the RF section. And this one here covers AM, FM, FM narrow, FM normal, and FM wide. And then you have the option of doing a 400 or 1000 kilohertz tone, or you could add your own, and you can see you could also do AC/DC coupling, I believe. Then we have calibration for our FM, our light in case FM is overmodulated, and then our level controls or gain control for that. And if you don't want a 400 hertz whatever tone, you can input your own, and then you can control the gain with this. On this one here, this module covers from 1 megahertz all the way up to 2.6 gigahertz, and it's the RF gain is done through this control right here. And you could also override that by doing this right here. And so each section you're into, you can control its minimum and maximum. And it does have a in connector, and I just put this little adapter on there. I'll go ahead and leave that one off because we're going to use that in a little bit. The main frame, which is the body, because like I said, these modules do pop out, consists of the counter and some controls there, and then for our sweep, output of the sweep, but it also goes through that port as well. And then we've got our keyboard and our resolution, because we have this really cool knob, and I tell you, I've really come to enjoy this knob. Instead of punching up, oh, you hear that? That really nice cool sound the keyboard gives. If you want to go up a few kilohertz, megahertz, whatever, you've got control right here. So it's really, really nice to have. Really like that. And you can control your steps instead of what they offer here. You can change your steps, program your steps how you want to do it. And you could also program your sweep mode. So if you want to do a 1 meg sweep, it'll do a 1 meg sweep. You want to do a 1 hertz sweep, it'll do a 1 hertz sweep. So really cool. I guess my only negative thing I have to say about this unit in whole, or at least at the keyboard level, is when you're entering in your desired frequency, there's no display up here. If you feel that you messed up, then you just hit this clear keyboard. I don't remember if this one has any options in it, but this one here does. It has option 03, I believe it is. We also have reference in and out ports, and then we have our GPIB connection and a really nice big fan, which on that one I had to lubricate and make it a little bit quieter. And boy, let me tell you, as far as noise is concerned, these things are loud. You run it about 10 hours, you'll be glad when it's off. So if we look at the front panel here, we'll see that it is the same thing. In my last video on the devices, I made mention that these modules can pull out, and they do. And I'm going to show you that in this video, because I have since played with them and got a little bit more proficient at it. Now, looking here at this documentation on them, they made 3 versions of the mainframe, and in this documentation we're only seeing 2 of them. This is the first one, and it's really cool. Got all these little lights up here. It's really awesome. I wouldn't mind collecting all 3, to tell you the truth. And then this one's mine. This is the popular one, and it ran for quite some time. In case you want to see some specs on it. And here we have some of the modules, different modules that can go into it. I have purchased some of these. I own this one. I own this one. And I own that one. These things were not cheap. They're very expensive. As you can see, just for the mainframe for mine, it was $12,500. And then on this new one, option 3, that ran you $155. And this one here ran $6,500. That's one I own. And then this one here is $3,500. So as you can see, it was not cheap, and these are lab grade signal generators. Okay, so to pull these modules out, down at the bottom here, up underneath, you've got these screws right here, and you have to remove these screws. That was my problem last time, so I didn't demo it. I said it was very hard to pull out. And you got this little tab here, little aluminum tab. You just kind of pull it inward, and you see it kind of collapses, unlatches, and then you get it out and give it a tug. Now these ones, I put a little lubrication up top, little 3-in-1 to make it slide a little easier. And you cannot mix these modules up with one another. I'll pull the other one out here real quick. Okay, maybe not so quick. And that weighs a ton. So you can see they're definitely not able to put them in the wrong hole. So all the electrical connections on this module is done through here. And then we have these two ports right here, and that's where the RF is done. Not all the modules have the RF port though. They're done through the contact pins. I would hate to service one of these. They would not be fun. You need cables for them, and the cable kits are going for about $600–700 on eBay right now. And to put those things back in, it's just the opposite of how you took it out. Got to get those guides into those channels right there. And that module probably weighs about 20 pounds at least. And then for this one, it needs a little slamming. And just like that, and then put those screws back in, tighten those down, and you won't lose those modules. But if you've got it sitting flat, and like I said, they're very heavy, it would be a pain to get those back out. Luckily, it kind of hangs over from my shelf here, and so I was able to get to those screws easily. Okay, I went ahead and removed the 4 screws here holding this top on and broke the seal just a little bit. Let's go ahead and finish opening it up. Get my light out of my way. Alright, so a big chunk of aluminum with breathe holes. And now, the good stuff, I reckon. Let's do a flyover on it. Little caps. And here are our 2 modules we just pulled out and looked at. And then a wide view. My flashlight, see if we can get some light in there. And this here is the keyboard area. Well, that was pretty awesome. I went ahead and took the opportunity of pulling out all those screws, about that many, and we're going to look underneath these covers to check out what's in the cavities. Now, I have loosely pulled this one up because I couldn't contain myself with the excitement. And that's about all I did, and then I put it right back down. I could tell you there is no RF shielding gasket in there. So let's go ahead and pull them up now. One other side note about the screws, I can care less, I'm sure. These are really soft metal, so you got to be very careful about stripping them. I had to put a lot of pressure in there to ensure I didn't do that. So let's check out this awesome board. Let's just do a quick flyover this way. And then we will come back and look at it like this. You can see there that the traces are nice and gold. That's probably why this thing weighs so much. There's some things that need to be turned, so I should get my golden screwdriver and twist and turn them, see what happens. Of course, you know I'm just joking, right? So that canister, in case I didn't show it, is the reference oscillator. I'm gonna lay these down over there the way I pulled them off. And so this one right here is our reference, divide by 2. You'll use your awesome Common Core math, I guess. I don't know. Now I'm seeing these really now first time with you. Figure out my lighting a little better here. There we go. Now we can see it better. And this one here is our reference divider. Wow, big massive resistor there. I'll let you punch those up if you're interested in knowing what they do. And okay, so this here is one lid, and it's going to be our phase detector. Trying to see if I can get a date off of that. Looks like 84 maybe. Yeah, 84. So this is well, at least 1984. So that's good to know. I wasn't sure exactly when it was made. Got some wires coming in. Very, very cool. Guess maybe I could have pulled that so we could see what's under there. Let me do that. Okay, I've got the screws removed out of that, and so we'll be looking at this for the first time with you. Oh, maybe. I didn't see these little guys, of course. All right, let's try that again. And real quick so we know what we're looking at. Oh, cool. All those little cards. Let's see if I could pull one. Just grab one out of random. I'd imagine you'd want to do this two-handed. There we go. That is cool. Not sure what it does, but it's cool. Hey, there you go. Made in USA. Tested by number 27. Hope they did a good job. Oh, more things to turn. How exciting. Some more 84 date codes. So very cool. And we'll pull our last card out, and then we will reassemble this, flip it over, and look at the bottom. I'm not sure what there is to look, but we're going to find out. Now, of course, you know, I cannot begin to tell you what any of this does. That is above my pay grade. But we get to look at it just the same. All right, got it all flipped around. Since I got this flipped over and before we pull this off, I have not looked at the bottom yet. Those screws that I was telling you about earlier in the video in regards to pulling out these modules, here they are in place. So, with that said, let's go ahead and pull the case. Oh boy, look at all those screws I'm not going to undo. It's a wide picture. Down here into the power supply section. This big cap. That 9,000 microfarad. Got it. Got a fuse. Good to know. Because see, there's a fuse back here. Oops, my camera all caught up. There's a fuse right here. So, wouldn't have known one was here otherwise. Okay, so now that was the power supply board. Let's do a flyover of this. Wonder if that's my 10 meg reference. And of course, I'm not going to remove the caps on all of these. We can just use our imagination. And you'll notice that diagonal black line that goes down the tops there. I think that's kind of cool. That way you can't put the wrong cap on the wrong slot. I think my IFR is designed the same way. And I should have grabbed the paper, but let's see what this thing does. What it pulls as far as amps and watts. Now right now I have the device turned off and it's just plugged into here. That's it. And so you can see we're half amp or less just sitting with the device turned off. And about 20 watts, 0.20 watts. So let's go ahead and turn this on. You hear a nice big swirl from the fan. You see we got the oven light. Now let's come back up here. Almost 23 watts and amps. About 2.5. think I need to come in and resolder. That does come back eventually. But I very infrequently use this device. But it's nice to have when you need. See how it's back? Interesting. All right. I got this frequency counter here. This is a Victor VC3165 frequency counter, and we have seen this in a previous video. And we know that with my other signal generator that it does pretty good. Covers the entire spectrum pretty much. All right, so the RF connection here is done through a in connector, and I'm going to have it connected to an in connector to BNC adapter, since most everything I do is via BNC connectors. Just put that on, screw that on. Now when you turn the machine on, it automatically defaults to 1 megahertz. We'll plug that in. We got the RF ported down. We'll plug this in. This has been warmed up for maybe a half hour now. And let's go ahead and turn this up. And automatically, I was looking at the wrong device. I say automatically, it popped right up. So there we go. And we're down here at 0.3 milliwatts scale. So I'm sitting at an angle. I cannot begin to tell you exactly where we're at. So now we're at the 0.01 screen, it looks like, and we're about there. I can't make the number out, apologize. Alright, so with that, we're going to go ahead and just hit up some frequencies, nothing too spectacular. I was telling you about this control knob. This is really cool because instead of punching it up on the keyboard, you just rotate your knob. If you're into, twizzling knobs, here you go. And I really like this knob. If you want to not go so coarse, you put it on medium. And yes, I know that this is not showing the right character. Although it should be. And then you flick that one over there. Let's go ahead and turn this up. That could be part of my problem. Not all my problem. Well, it's been about 4 hours since the last time I attempted in filming. I was going to go through and demo this and just run through the frequencies and just to confirm one last time that everything was a go before I pulled out the old one and put in the new one. However, that did not turn out very prosperous. I'd punch in 1 meg, I'd get 1 meg, I'd start going through the dial, and it'd be fine, and then it stops working. Have some dead spots in it, and then I'd go back to 1 meg. Love those buttons. And I wouldn't always get 1 meg, even though it would demo 1 meg here on the frequency counter. I would get 2.2 something meg. And I've tried 2 other frequency counters, and all with the same results. And then with this one, I'd get up about 1.5 gig or so. And even though everything looks normal here on the frequency counter, it started to peter off and just would not excite the frequency counter. Put it on the O-scope and it just looked goofy. Did not look right. I've pulled out my modules from my known good working signal, almost called it a signal tracer, my signal generator, and my 2 known good modules. Put them in here. Matter of fact, this is the one from there. And the modulation worked fine. Had no issues with the modulation. But with the RF module, weird. I think this RF module also has issues. So when I put this one in there, it would work, but I got up to that 1.5 gig or so and it petered out. I also noticed going throughout the whole entire spectrum, I would have weird lulls, meaning that the meter would deflect and reflect a lot. It didn't really stay steady. Normally what I would see is, a little wiggle in it throughout the band, and that's normal. But man, it moved a lot. So I sprayed some contact cleaner, electrical contact cleaner, on the contacts in the rear and ensured that it was stabbed in well, and I cleaned the RF connector. Made no difference. Tried it in there, did the same thing. Made no difference. Modulation, however, these modules work just fine. I unfortunately am going to conclude this video, and I am unfortunately not going to put this one in line. I will keep this one out. Of course I'm going to keep that one out. I'm going to keep that one in line, this one out, of course. And I do have more test gear. My workbench is ever growing, ever changing, and we will review those pieces of test gear in future videos. I have more test gear than you'll ever know. I have almost a Mr. Carlson starter kit. With that, let me thank you for watching this episode of Test Gear Tuesday, even though I didn't say that at the beginning. That's what this is. We will catch you on the next one, and your support, I do appreciate it. See you later.